Alright, so let's talk about the analysing section of the report. There's three things: correct and relevant processing of data. Okay, so there's a couple of things we need to look at here. Firstly, we need to do our sample calculations. Right, and so I think as a general rule, I show a sample calculation for things that you had to do manually, right? So for average and standard deviation, I just make this statement here saying that you use the built-in algorithm in Microsoft Excel, and I just said what that function was. Then I think it's really important here to say with the p-value, or the how you calculated that. So student t-test calculator, two-tailed, two independent means t-test, something like that, and then also state what the significance is. All right, so then you need to do your sample calculations table, and so it's worth doing that for anything that you've done that didn't, wasn't a built-in algorithm. All right, so a simple table here, and so that's the formula. So I just used that insert equation function, and then so you use one of your examples and you actually put real data in, state what that data's from, and then also down here, once you've provided the formula, you need to actually say what those things actually mean. Okay, so that's pretty straightforward, and to actually get those the formula, or to actually get those symbols in that particular format, then you actually insert a equation. Now, just a word here for standard deviation. S is the function of standard deviation. It's the symbol for standard deviation in maths methods. So that's what we're going to use. And also the x hat is the one for mean. Now, in terms of getting x hat, all right. So we're going to go x, but then we're going to go accent, and we're going to find the hat. Okay, now we're going to go x here. All right, so that's how you get x hat. So what we're doing here is showing that you're using correct and relevant processing of data, and then of course the other way we illustrate that is by when you present your data as well. Your teacher's probably going to be checking to make sure that it kind of makes sense. Okay, look, we use relative standard error as another measure. So you're probably asking, okay, so why do you use standard error? Look, when you've got a small sample size, standard error is better than standard deviation. And the reason for that is because it's the square, it's the standard deviation divided by the square root of the mean. So it kind of adjusts for a small sample size somewhat. Okay, now what do we do? Relative standard error, well, as you can see, it's standard error divided by the mean times by 100. So what it does is it allows you to compare, or the uncertainty between your conditions by comparing it to the mean. So that's really handy. So the other thing we're looking at with the processing of the data is making sure that the way it's being presented here is correct. So correct and relevant processing of data also includes how you present your data in graphically. So you need to make sure that your y-axis starts at 0. You need to make sure that you've labeled your axes. You also need to make sure that you've included error bars, and this is an important point here. You need to state what your error bars are. So after your title, now in terms of the title of the graph, or the figure, you will see that it's essentially the same as the title of your table. And at the end of it, put in brackets what the error bars are. Okay, so in this case, it's standard error. So do make sure you put your error bars in, and I've got another video showing you how to do that. All right, now, so the next thing is thorough identification of trends, patterns, relationships. So what we've got here is analysis and interpretation. Basically, your analysis is the thorough trends, etc. Interpretation is linking it back to the literature, or back to the science. Okay, so you can actually do it quite. You can actually thoroughly analyze your data really quite concisely. So this is your independent variable, and then you're making a statement. So statistically significantly, what that's saying is it's related to your p-value. Okay, so you're making a judgment. You can see here that p-value. Note that I've centered this because there's one p-value comparing the two conditions. Okay, now you can see that's statistically significant. So I'm saying that my independent variable, my dependent variable was significantly lower when this condition. And then I'm saying what the mean was, plus or minus, and I'm sure you know how to do plus or minus, but I can show you. Insert advanced symbols, and you will find plus or minus just there. Okay, plus or minus, and then we're saying this is the standard error. Now I'm saying this specifically the first time, and then after that I'm not saying it. So it's this condition compared with the other condition, and then state the mean and standard error, then state the p-value. Now, importantly, you need to justify why you've made a decision about that being significant. So I've just said here the difference is significant because the p-value is below that threshold of significance, and then state what that is. Now, you've said a lot in a very small amount of time, a very small number of words. Now, the next thing is I've linked it back to the science. Now, if you've got a couple of graphs, then you're going to, or a couple of figures, you're going to describe in a bit more detail. The next part is thorough and appropriate identification of uncertainty and limitations of evidence. Okay, so we have something similar to that in this next section, which is justified discussion of the reliability and validity of the experimental process. Okay, so I want you to understand here that we're looking at the limitations of the evidence. Okay, so we're evaluating the quality of the evidence. How good is that evidence to be able to answer our research question? And then down here, we're actually looking at the experimental process. Okay, the evidence, the method. Now, they do link together because if the method's poor, increases the uncertainty. All right, so what are we looking at here? Thorough and appropriate identification of uncertainty and limitations. All right, so make the statement here, uncertainty and limitations. This is when you're going to talk about standard error, relative standard error, and error bars. All right, standard error, relative standard error, and error bars. Now, you're going to make a judgment about, are they the same, or is one larger than the other? You're going to make a judgment about the size of it in terms of your uncertainty. Okay, so I've made the statement here, standard error for these two conditions, and I've stated what they are, suggests that the level of uncertainty was very similar. Okay, easy statement. If one was bigger, you would suggest that the uncertainty was greater in the one that was bigger. Relative standard error, and I've stated what it was, and said that one was higher than the other. And what does that suggest? One had greater uncertainty than the other. Okay, pretty straightforward. Now we're talking about the error bars. The standard error, so we're talking about these error bars here. And I'm making a judgment, qualitative judgment, saying that the error bars are moderate in size, but they don't overlap, and indicating that the values do not fall within the same range. And it suggests the difference is due to the independent variable and not due to chance. Okay, so something like that. So what do the error bars mean? It means the spread of the data. Okay, now if you've got really large error bars, it means that you've got really large uncertainty. You can't say, because is the mean the mean that you measured, is that the actual mean? If you've got large error bars, the mean can actually be up here or down here. And if that's crossing over or overlapping with the other condition, whether any difference is due to the independent variable or whether it's actually due to random chance.
So we can make this sort of statement here. So if you said that the error bar, the error bars were large and overlapping, you would say that that there's a high likelihood that the difference is actually due to random chance and not due to the independent variable. Okay, and then I've just made this statement here, bringing in the p-value again. So that is uncertainty and limitations of the evidence. It's basically saying how confident are we with this data that it is really addressing the research question. Okay, all right, so that's nearly it. And then we've only got one more to go, interpreting and evaluating.